Good morning, students. Today we are going to learn about tree traversal techniques in the third unit. So we all know the third unit is for nonlinear data structure. Hope you remember what is linear data structure and what is nonlinear data structure. So in nonlinear data structure, we are going to learn about tree traversals. The main objectives of this topic is to learn about how to traverse a binary tree, and we have to study about the different types of traversal techniques, namely inorder, preorder, postorder, and we have to solve an example for each category. Before going into the topic, first we have to know what you mean by traversing a binary tree. So what is traversing a binary tree means? It is the process of visiting each node in the tree exactly once in a systematic way. Okay, what is traversing a binary tree? It is the processing of visiting each node in the tree exactly once in a systematic way. Okay. So while considering the linear data structures like stack, queue and all, you can visit all the elements sequentially, but it is not true for nonlinear data structure. In nonlinear data structure, you can visit the elements in many different ways. Okay. So once again, what do you mean by traversing? Traversing is nothing but how we are visiting each node in the tree exactly once. Okay. So as I told already, we have three different traversal techniques. One is inorder, second one preorder, and the last one postorder. What is inorder traversal? So you can remember the inorder traversal with the key node left, root, right. Okay. So that is left, then root, then right. Okay, this is how inorder takes place in binary tree. So to traverse a non-empty binary tree in inorder, you have to follow the following steps. First, we have to traverse the left subtree. Then you have to visit the root node. Then you have to go with the right subtree. Okay. So in order to traverse the left subtree and right subtree, you can call the same procedure for left subtree and right subtree. That is, you can call inorder of left subtree, then visit the root, then inorder of right subtree. So this is called recursive function. So this is the algorithm for inorder traversal. So hope you remember what is inorder. Visit the left subtree. Okay, traverse the left subtree, then visit the root node, then traverse the right subtree. So nothing but, in order to traverse the left subtree, you can call the same function inorder. Okay, but the argument is the left subtree of the given binary tree. After traversing the left subtree, you are moving to the root node. Just we are printing the root node data. After printing the root node data, we have to traverse the right subtree. So to traverse the right subtree, again you can call the same function, but the argument is right subtree of the given binary tree. Okay, so that is the recursive function concept is used here. So inorder traversal is also called as asymmetric traversal or LNR traversal algorithm. Left node right traversal algorithm. Okay. We move on to the example. So consider the given binary tree. Okay, the binary tree, the root node of the binary tree is A, and the left subtree of this binary tree contains the elements D, B, E, and the right subtree contains the elements F, C, G. Okay. So what is in order? Left, root, right. So traverse the left subtree. So again, it is nothing but to traverse the left subtree, again you have to apply the same concept, that is left, root, right. So here the left is D, then root is B, and then right is E. So now we have finished traversal of left subtree. Then go to the root node and print the root node data. So that is here. So A is printed. After finishing the printing of root node, traverse the right subtree. So traverse the right subtree. It is nothing but it is again the tree. So we call the same procedure. Left, root, right. Left, root, right. Okay, so left is F and root is C and the right is G. Okay, D, B, E, A, F, C, G. So this is the given in order traversal of the binary tree. Okay. So it is shown in the diagram. First we are visiting the node D. Then from D we are moving to the root node B. Then from B to E. So now left subtree traversal gets finished. Move on to the root node A. Then traverse the right subtree, that is left, root, right is applied for right subtree. F, then the root node C, then the right node G. Okay, so hope you understand what do you mean by in-order traversal. Next we move on to the pre-order traversal. So true pre-order traversal is nothing but root, then left, then right. Okay, so this is how we are visiting the nodes in the binary tree. So the algorithm for pre-order is visit the root node, then traverse the left subtree, then traverse the right subtree. To traverse the left subtree, we are calling the same function preorder, but the argument is left subtree of the given tree. To traverse the right subtree, we are calling the same function preorder, but the argument is right subtree of the given tree. Okay, that is we are using recursive function concept here. So this is the algorithm. So what is preorder? First the root node, then the left subtree, then the right subtree. Okay. So the other name of preorder traversal is depth first traversal or NLR traversal, where NLR is nothing but node left right. Okay. So first we have to print the root node data, then you have to traverse the left subtree. So to traverse the left subtree, we are calling the same function preorder, but the argument is left subtree of the given binary tree. After traversing the left subtree, we move on to the right subtree, that is traverse right subtree, call the same function preorder, but the argument is right subtree of the given tree. Okay, we will see with one example. So what is preorder? Node, then left, then right. So first the root node is printed. Okay, that is A. After printing the root node, you have to traverse the left subtree. That is again it is a tree. For this tree, you have to apply the same concept, node, left, right. Okay. So the node is printed, then left, then right. So we have finished the node, we have traversed the left subtree, we move on to the right subtree. Again right subtree is a tree. For this tree, you have to apply the same concept, node, left, right. So node is C and left is F and the right is G. Okay, we will check with the answer A, B, D, E, C, F, G. Okay. So see the diagram. First, the root node is printed. Then traverse the left subtree. So left subtree, again the same concept is applied. Node left right, that is B, D, then E. Okay. After finishing the left subtree traversal, move on to the right subtree. Again apply the same concept, node left right, that is C, F and then G. Okay, hope you understand what is preorder traversal. The next topic is postorder traversal. So postorder is nothing but left, right, then the root node. Okay. So the algorithm for postorder traversal is traverse the left subtree, traverse the right subtree, then the root node is visited. So to traverse the left subtree, you can call the function postorder, but the argument is left subtree of the given binary tree. To traverse the right subtree, again call the same function postorder, but the argument is the right subtree of the given binary tree. Then the root node is printed. Okay. So we move on to the steps. So what is postorder? Left, right, then the root node. Okay. So the other name of postorder algorithm is LRN traversal algorithm. That is left, right, node. Node is nothing but the root node. Okay. So we are calling the postorder function for its left subtree. Then we are calling the postorder function for its right subtree. After traversing the left subtree and the right subtree, we are printing the root node data. Okay. So that's about postorder traversal. So we are going to see with one example. So what is postorder? Left, right and then root. So traverse the left subtree, then traverse the right subtree and then finally the root node. So traverse the left subtree. Again it is a tree. Apply the same concept, left, right, root. So left is D, right is E and then root is B. Now traversing of left subtree is finished. Go with the right subtree. Now we are going to traverse the right subtree. Again apply the same concept, left, right, root. That is left is F, right is G and then root is C. So now left subtree is traversed, right subtree is traversed. Move on to the root node and the root node gets printed. So it is A. So check with the output D, E, B, F, G, C, A. Okay. So this is how postorder traversal takes place. So first traverse the left subtree. For the left subtree also again apply the same concept, left, right, root. That is D, E and then B. After finishing the left subtree traversal, move on to the right subtree. Again apply the same concept, left, right, root. F, G, C. Left subtree is finished successfully. Right subtree traversal is also finished successfully. So move on to the root node. So root node is printed. Okay. So that's about postorder traversal techniques. So some of the gate questions. Is it possible to construct a binary tree uniquely whose preorder and postorder traversals are given? So the answer is false. You cannot able to construct a binary tree uniquely once preorder and postorder traversals are given. Okay, the answer is false because we can go with different binary trees. The second question is, sometimes the post-order traversal or in-order traversal, some traversal is given and they ask you to compute the height of the tree, or they may ask you to compute the other traversals and so on. Okay. This is also another one example. These are some possible gate questions. Thank you.